right angles in geometric figures. So some geometric figures have right angles all around them. So like an isosceles triangle. So these two sides are equal. If you bisect the third side, like you cut it in half, then these two sides are equal and then makes a right angle. Same thing with the equilateral triangle, right? All sides are equal. Well, if you cut that in half, then it's going to bisect this angle on the side, and then it'll form a right angle, which we can use like SOHCAHTOA 1. Rectangle squares by definition have corners. All the corners are right angles. So if you make a diagonal, then you have a right angle right here, right triangle right there, and a right triangle right there. That's all. Because remember, that's all we have right now is right triangles. So we want to be able to use them as much as possible. In a square and a rhombus, when you draw the bisectors, they form right angles. In a kite, the diagonals intersect at a right angle. And then we have circles. The key here is a radius and a tangent line. They always form a right angle. So if you have a radius and a tangent line, that's a right angle. If you have a semicircle, this is 180. So when you do a semicircle, that's half of that thing. So it's 90. And then one we're going to see a lot more of, if you have an angle here and you have a chord and you bisect it, well then since you bisect it makes a right angle because you cut it in half perfectly. These two sides are equal. And then don't forget it's a radius. So that means this corner and this corner radius. So it's kind of like an isosceles triangle. Okay, with that all in mind, let's do a couple examples where we have to actually apply it. So we have to find the unknown stuff here. So this is not a right triangle, so the only thing we know right now is how to solve right triangles. So let's make it a right triangle. Let's cut it in half. It makes that a right angle. We bisect it perfectly. So if that's x, this is x also. Or you could say this is 67, that's 67. And then I just gotta solve this right triangle right here. We have a right triangle that looks like this. 67. This is x. This is my right angle. The whole base is 10, so if we cut it in half, this makes this 5. And we solve this like we solve anything else. Highlight your angle. This would be opposite. This is the right angle, so this is hypotenuse. And this is adjacent. We have hypotenuse and adjacent what we want, so that is CA. So cosine of 67 equals 5 over x. And then we just solve it. So multiply both sides by x and divide by cosine of 67. Don't forget we use the calculator for that. Let's turn this on. When we do that, we want to make sure we're in degrees. See the degree sign there. So you go to math. Sorry, go to mode. Make sure you're in degrees. Get out, and then 5 divided by cosine 67. So x equals 12.8. You do 366. So that's the idea. Let's do the next one. They want us to find the angle. So again, we don't have rules yet for how to do non-right triangles. So only thing we can do right now is cut in half. And it makes this a right angle. These are cut in half, so if that's 5.2, half of that would be 2.6. We're going to use that to find this angle here. Let's call that x. Right, so I'll find the angle there. Well, that's my angle. This is opposite. This is hypotenuse because it's opposite the 90-degree angle. And that makes this adjacent, which I don't care about. So we have hypotenuse and opposite sets. So my favorite trig function, sine of x equals opposite of hypotenuse, 2.6 over 8.3. Right. Sine is opposite of hypotenuse, we get this. Remember the way we solve this is we want to get rid of the sine, we do the sine inverse of both sides. That way the sines cancel out and you get x equals whatever sine inverse of that is. So second sine 2.6 divided by 8.3. We get 18.25. Now remember, this is not my answer because I was only in this part of the angle. I need the whole thing. Now again, we did bisect, cut it in half perfectly. So these two things are equal. So my theta will just be twice that. So let's get my answer and times it by 2. 36.5. I guess my alpha. That's the angle there. 36.5-ish. So there we go. Let's do another one. The rhombus has diagonals length 10 and 16. Find the smaller angle of the rhombus. So we have a rhombus. So rhombus is like a square that's been turned to the side. something like this. Not perfect, but that's the idea. Right, we have two diagonals. We have one that's length 10 and one that's length 6. So in my case, here's a shorter one, 6, and here's a long one, that's 10. The inside makes 90-degree angles, and they also bisect each other. So these two sides are equal, and these two sides are equal. So this is 6, and that is 10. Find the smaller angle of the rhombus. So I want the smaller angle. So there's two angles here. There is this one, and then there's this one. Right, these two opposite ones are congruent, and these two opposite ones are congruent. So if I just look at the triangle I have there, not the best right triangle. Right there. Right, this is 10, this is 6, the right angle is right there, and a rhombus, the middle is all right, the right angle. And I want the smallest angle, which is half of this one. Right, the smallest angle is this one, so this would be half of that one to do it. Also, if you're not sure, the smaller side gets a smaller angle. So this is 6 and that's 10. This is a bigger angle than this angle is, because this side is 6. 6 is the smallest angle, 10 goes a bigger angle. Right, it follows the side. Anyway, the general idea is I'm looking for this side. And I need to times it by 2 because I need to find the whole angle. Well, what do we have here? This is opposite. This is adjacent. This is hypotenuse. Right, here's my angle, opposite is opposite, opposite right angle is hypotenuse. And then the missing side is adjacent. The other side is adjacent. We have opposite and adjacent, so we have tan. TOA. So tan is opposite or adjacent, so in this case it would be tan of my angle would equal 6 over 10. We're going to do tan inverse to get rid of it. Right, take tan inverse of both sides. And we would get let's say about 31. So this angle here would be 31. Now, I think they mean the whole smaller angle of the radius, so we're going to times it by 2. Equals 62. That's a smaller angle of the radius. The rhombus. So we get that. By the way, if I want to find the larger angle, since I know that's 31 and this is a triangle, I could just do 180. So if I was trying to find that, I could just do 180 minus 31 minus 90. And I get like 59. And I can times that by 2 to get the bigger side. Next one. We have a trapezoid to say. I want to find x there. So in this case, probably need to find this guy. Right? That's my right angle. But I don't know what the bottom is, I don't know what the height is. But if I go over to this side and I do the exact same thing, well, I could use this side to find out what the height is, right? Like this is an x. Whatever that x, I guess I don't want to use x that are using x. This is a y, and whatever that y is this y. And once I find that, I could use triangle methods to find x. So let's go with this side first. Now again, I always start the same way. In my mind, I go, okay, what are my sides? This is opposite. This is hypotenuse, right? Because there's a right angle, so that's hypotenuse. There's the angle I'm looking for. It's opposite side of that. So if I do, so that should be sine. So sine of 65 equals y over 10. So multiply both sides by 10. You get 10 sine of 65 equals y. Let's put that in a calculator. I get 9.06 equals y. Okay, so I can use that in my other triangle. My triangle here is my triangle. Here's 48. This is 9.606. This is say 9.1 probably. And I want to find the hypotenuse. Now again, I cannot do a squared, b squared, c squared because I'm missing a side. So I'm gonna have to do SOHCAHTOA again. Here's my side, and it's sine once again. So it's sine of 48 equals 9.1 over x. Try to make it a little tougher. I'm just gonna multiply by x and divide by sine of 48. So I'm gonna get x equals 9.8 divided by sine of 48. Right, all I did was multiply both sides by x and then divide by sine of 48. Let's put that in my calculator. And I get 13.2 if we round 36 figs. So there we go. Let's do another one. This might be the last one. A circle has a radius of 6.5. The chord of the circle subtends the angle at 112 at its center. Find the length of the chord. Okay, so let's draw this out before we do anything else. There's my circle. It has a radius of 6.5. Now, this means that all they're saying is that the angle in here should be 112 degrees. So again, it doesn't be perfect, just a sketch, but 90 will be a right angle, so I'm going to go a little past that. I'm going to say this is 112. And now again, since it is a radius that's 6.5, this is also 6.5. And they want you to draw a chord that connects the two edges. So something to like that effect. Let me do it again. This is 112. Okay, so what we do next is draw the chord that. Just cut this chord in half because we want a right angle. So we're going to cut it in half perfectly. So what's going to happen there? Whatever this side is that side. So let's make that our x. Because we want to find the length of the chord, so let's say that's x. This was 112, I cut it in half. So 112 divided by 2, which is 56. So if I just look at this like right side of the triangle, I have this. Right, this is 56 because I divided up 112 by 2. This is 6.5 because it's the radius, and this is what I'm looking for. And once I get the answer, I'm going to times it by 2. So, just do what we always do. Label the sides in your head. Okay, here's my angle. That makes this opposite. This is hypotenuse because it's opposite the 90. Another one of my favorites, we're doing sine again. Right, O and H. So sine of 56 equals x over 6.5. Let's multiply both sides by 6.5. Put that in our calculator. We get 5.39, I guess, if we're doing 36 figs. So again, that is this side, 5.39. I want the whole chord, so I'm going to multiply that by 2. If we're doing 36 figs, it's 10.7. So chord length is, what was that, 10.8. I think I meant to say centimeters. And that's the idea.